Alright. In this video, we are going to look specifically at some polynomial division. So when I'm talking about polynomial division, we're talking about either long division or what's called synthetic division, where we are essentially, instead of just dividing, say, straight numbers, we're now actually dividing expressions or polynomial functions. Okay. Now we use these division ideas for any polynomial that is not easily factored down into its parts. And so what the division does is it allows us to take parts of the polynomial away or simplify it so that we can actually reduce all the way down to an end result. Well, doing that says that we actually have a method or different parts of your division that we have to keep in mind. Okay, so first and foremost, when we are talking about the division, we are talking about the old school division sign. So if you remember way back, we're talking about your division sign that looks something like this. Where remember, you have the stuff under the division sign and what you're dividing it by is out on the outside. Well, with those, we now actually have expression labels that we use. So first and foremost, the junk that goes underneath is the polynomial that we are trying to reduce. So we call that p of x. Now the other piece we have is we have the stuff we're trying to divide with. So we like to call that one the divisor, and the divisor is going to be d of x. Now once we run our division, we have to know what our results or our answers are going to be. So we call that your quotient. So this is going to be obviously q of x, so that's going to be your solution. But then a lot of times, if you remember old school division, we ended up with a remainder, and so we then would have plus your remainder, r of x. Now that is how you're going to essentially set up all of your division problems. Okay, so remember your numerator here, so the numerator or the top is the solution. Okay, what's inside the division is the polynomial you want to reduce, and what's outside is your divisor. Okay, so right here again we have the reminders. Your divisor is d of x, it's the stuff on the outside. The polynomial is p of x. Your quotient or solution is going to be q of x, and the remainder, so what pieces are left over, is r of x. Now, that being the case, we then also have a specific way that we are writing your answers, and so that comes down to this formula here, where we would state that your overall polynomial is the same thing as your divisor times the quotient plus your remainder. Okay? So with that, I want to take a look here at an example of an old school method using long division to figure out what that quotient and remainder is. Okay? So first and foremost, you will be given the identifier. So here we're telling you p of x is the following and divisor or d of x is the following. So you essentially need to set yourself up. So what I like to do is go ahead and set myself up a big old long division and then put the information I have. Now with this you have to step down, which means you have to include every term. If you look at your polynomial, we have x to the fifth, but then we skip all the way down to x squared. Well, in between these two would be x to the fourth and x to the third. They must be included in your division. So they get represented with zeros. What do I mean by that? We started with 2x to the 5th. Then we have 0x to the 4th, 0x cubed, minus 3x squared, plus a 0x, plus 1. And my divisor was almost long enough. Okay, so notice I've included every single power stepping down in descending order. Now, my divisor was x squared plus 1. So on the outside over here is going to be x squared plus 1. So this is your divisor. Now, remember old school long division. In this case, what we have to look at is we have to look at just this x squared piece. And you will say to yourself, x squared can go into 2x to the 5th. So ignore all the rest of this. We're just looking at this first term. So x squared can go into 2x to the 5th how many times? Well, in order to turn an x squared into a 2x to the 5th, first we need to multiply it by 2. And then in order to turn square into the 5th, we have to add 3. So off to the side, I like to do what are called my division notes, which essentially means that I am going to do the math. So here I have the 2x to the 3rd, because that's what I needed to turn this into 2x to the 5th. And I have to multiply this by the x squared plus 1. Okay? Why? Because that's the whole thing that's on the outer side. So again, let's look at that real quick. In order to figure out what I have to multiply by, I look at just the variable. And I have to ask myself, how do I turn this variable into the term underneath my radical? So how do I go from x squared to 2x to the 5th? Well, we multiply that by 2x to the 3rd. To do my actual division, you would have to multiply by your whole divisor. Okay? So in this case, when we do it, what we're going to end up getting is 2x to the 5th plus 2x to the 3rd. If you remember from long division, you then take that multiplication and you subtract it. So here, what we're going to do is we are going to subtract, and I'm going to open a parenthesis here, and I'm going to subtract what I got, which was 2x to the 5th, and then plus 2x to the 3rd. And I'm going to close my parentheses, and I'm going to do this little math here. So 2x to the 5th minus the 2x to the 5th is going to leave me with a 0. And up on the top above it was my 2x to the 3rd. Now I need to come over here, and I have 0 minus a positive 2x cubed is going to leave me with a negative 2x cubed. Now, with this, obviously, I don't have any x to the 4th, so I can totally ignore. But on this next term, I need to go ahead and bring it down. So this is now going to be minus 3x squared. So with this, I now have a new first term to look at. So this first term to look at here is negative 2x cubed. So again, I go back to just the x squared. And how do I turn x squared into the negative 2x cubed? So we're looking at just this first piece here. So to do that says I have to multiply by a negative 2. And then to turn squared into 3 means I have to add one more. So this is a negative 2x. So I need to actually run my multiplication here. So I'm going to now have the negative 2x times my divisor, x squared plus 1. When I multiply, I get a negative 2x to the third, and then I have minus a 2x. So in this case, again, I'm going to subtract. I'm going to open a parenthesis. So this was a negative 2x to the third, and then I have minus my 2x. So again, I have to do my addition. So I'm going to do negative 2x cubed minus a negative gives you positive. So these cancel and give me 0. I need to pull down my negative 3x squared. And then I need to do 0 minus a negative 2x. Well, that turns positive, so this becomes plus my 2x. And the last thing is I can go ahead and carry down the plus 1, which has shrunk my equation down even further. So now, again, I have, how do I turn x squared into a negative 3x squared? Well, the first thing I need to do is multiply by a negative 3. And then x squared and x squared is the same, so I don't have to add anything else. Again, over in my notes, I multiplied now by a negative 3, and I got to multiply the divisor, which was x squared plus 1. So when I multiply that through, I end up with a negative 3x squared, and then this is minus 3. So again, I need to do my subtraction, and I'm going to open my parentheses. This is a negative 3x squared, and then over here I have minus 3. I'm going to go ahead and do the math. Minus a negative again becomes positive, so my first term goes away. I'm going to drop down my next term, which was a 2x. And then I have 1 minus a negative 3. So minus a negative becomes positive, so 1 plus 3 is plus 4. And now, how do I turn x squared into a 2x? Well, you can't, because there's nothing I can do to an x squared to make an x. Therefore, this piece right here becomes your remainder, and this part up here becomes your quotient. Now, with that, you would then write your solution. So your solution here would say that p of x is equal to q of x, sorry, let me write that, is equal to your divisor first. So we'll do d of x times your q of x plus your remainder. So in this case, we would have that p of x is equal to x squared plus 1 times 2x cubed minus a 2x minus 3 plus parenthesis 2x plus 4. Now, in some instances, we write your remainder in terms of a fraction. So another way that you could see it written is you could see it written as p of x is equal to your divisor, x squared plus 1, times your quotient, 2x cubed minus 2x minus 3, plus your remainder. So here this was the 2x plus 4, but we're dividing that by x squared plus 1. So there's two ways that you can see this written. Okay. You have to just kind of look at your directions to see which way your directions are preferring. Now, me personally, I like to do this second way because I like the way this remainder looks. It reminds you that this is still being divided. However, for some instructors, both ways are acceptable. Again, like I said, you just have to look at your directions. Okay? So that is an example of long division. Now, there's a few things that we need to know. Is that first, when we do our long division, we are setting ourselves up for a theorem that's called the remainder theorem. The remainder theorem says, if a number c is substituted into the polynomial f of x, the result f of c is the remainder obtained when you divide f of x by x minus c. So if you remember, the x minus c, this would be like your factor. Okay, so this part here is kind of the same as a factor. And so the remainder theorem is setting you up like this, where we're telling you that your factor times your quotient plus your remainder gives your polynomial. This factor right here is the same thing as your divisor. Okay, so when we're looking at this part here, what you need to do is you need to think that this is your divisor, d of x. Okay. Now, we do have a shortcut method. Your shortcut is called synthetic division. Synthetic division essentially is long division, but the only thing we do is use the coefficients. We understand or identify what that divisor is, and then essentially we just use the c part out of it. We need to remember that you need to change your signs depending on what's going on with your factor. And by that I mean if you see x minus c, well then that means your c is positive. Okay, so one thing to remember is that x minus c means the c is positive. This means that if you see x plus c, this means that your c is negative. Okay, so change your signs. So the easiest thing to do with synthetic division is to just simply see an example. Once you see an example, usually most students catch on fairly quickly. The other thing that you have to remember is this first part here that says if you skip a degree, then you need to put a 0 in for that term. You have to use 100% of descending order, just like we did in long division. So let's take a look at this example here. So I have x cubed minus 2x squared minus 8 divided by x plus 2. So a few things that we need to remember here. This was my p of x. This was my d of x. The other thing we need to remember is that in this case, c is negative. Why? Because this is x plus c, so c is going to be negative. So we set up our synthetic by drawing a little half box. What goes inside here is going to be your c term, and then what goes next, this is going to be your descending p of x coefficients. Okay. So let's go ahead and set this up so you can see it. So here is going to be where my c goes. So because, sorry, I couldn't see, because this said plus 2, your c is negative, so this is a negative 2 that goes in here. And then we have to look at your polynomial. So we're looking just at the coefficients. So here I have 1x cubed, so my coefficient is a 1. Then I need to step down to an x squared, and in this case I have negative 2x squared. I need to step down to x, to which I don't have any, so my coefficient there is 0. and then step down again to your constant, so in this case it is a negative 8. So I have input everything. Now how do we get started? The first thing you have to do is you have to drop down your first term, and this is going to start your new polynomial. Okay? So the way that it works is this. You're going to do box times the bottom and put it underneath the next. Okay? So it's going to go box times the bottom, and then it goes into this space. So I have negative 2 times 1 is a negative 2. And then what we have to do is we have to add. So I'm going to put a plus, but I circle it. This essentially means, let me use a different color here. So this right here means that we have to add vertically. So I'm going to do negative 2 plus a negative 2, which is going to give me a negative 4. Now I'm going to repeat. Negative 4 times the box. So negative 4 times negative 2 is 8. Put it underneath the next column. So this is an 8. Then I need to add the 2 together. 0 plus 8 gives me 8. Repeat. 8 times negative 2 gives me a negative 16. Then I need to add them down. So negative 8 plus a negative 16 is a negative 24. Okay, so what do we actually have here? This down here is going to be q of x plus r of x. So what are we actually doing? Well, I started with an x cubed. When I drop it down, this becomes x squared. So the coefficients represent the coefficients in front of your variables. So this is an x squared. Descend down, this becomes minus 4x. Descend down again, this becomes plus 8. Descend down, this is going to be then minus 24 over the x plus 2. Okay? So every time you do a synthetic division, you are reducing your exponent down 1. Now, when you're working them, if you are trying to say find all of your possible zeros, you would keep doing synthetic division until this last term here becomes a 0. So you want your constant term to go away. When your constant term leaves a value, that's your r of x. So what do we actually have here? We have that my q of x is equal to x squared minus a 4x plus 8. And we have that my r of x is going to be negative 24. So overall, my polynomial is going to become, again, q of x plus r of x. So here, again, we would have that my polynomial is my divisor, so the x plus 2, or you call it your factor, times your q of x, x squared minus 4x plus 8, plus your remainder. So here plus and then negative 24 over x plus 2. Okay, let's look at another one. So here, notice I have imaginaries or complex. So this one right here, these are complex polynomials, which means the I means imaginary. So we still can do the same thing. So here, again, I can still set up my box. And in this case, I have this part down here on the bottom is representing my x minus c. So here I have x minus 3i. What this means is that your c is equal to 3i, and so that's what goes in the box. So the 3i comes over here, and then we look at this top term, which is your polynomial. So here, the first thing I have is x cubed, so my coefficient is a 2. My second coefficient is going to be negative 10i. My third coefficient drops down again, so this becomes a 5. And then my constant is going to be 8 minus 3i. Again, to set things up, says you have to take your first one and you have to drop it down. And this is what sets up your division. Alright, so again, let's go ahead and do the work. We can do the same division notes that we need. So what you have to remember again is you're going to take bottom times the box. So what we're doing again is we are doing bottom number times your box, which is the c term. So here this is going to be 2 times a 3i, and when we do that we end up with 6i. So that's what goes up here. This becomes a 6i. We then have to add them together. So negative 10i plus 6i is going to give you a negative 4i. Now we need to do it again. So here, bottom, so a negative 4i times the box, 3i, is going to give me, so negative 4 times 3 is a negative 12, I times I is I squared. We need to remember that we have a fun little rule that says I squared is the same as negative 1. So negative 12 times negative 1 is going to give me 12 as a result. So that's what goes here. This becomes a 12. Again, I need to add these together. 5 plus 12 gives me 17. I now need to do bottom. So 17 times the box, 3i. And in this case, 17 times 3 is 51i. So up here, this becomes 51i. Again, we have to add them. So when we add them, in this case, I'm essentially adding 8 minus 3i to 0 plus 51i. So the 8 comes down, and I have negative 3 plus 51. So this becomes plus 48i. So again, when we look at it, this piece here is my remainder. This part here is going to be the coefficients of your quotient. So again, we want to look at creating your polynomial. So p of x is going to be that x minus c times your quotient plus your remainder. So here your polynomial is going to be the x minus 3i times your quotient. So we need to know what the quotient is. So my quotient of x is going to be, I started at x cubed, so I stepped down to x squared. So this is a 2x squared minus a 4ix plus 17. So here, my quotient again was the 2x squared minus 4ix plus 17, and then I need to plus my remainder, so this is going to be 8 plus the 48i, and the whole thing is going to be over that x minus 3i. Alright. Last but not least, again, what happens if we want to actually find your zeros? So, earlier I had mentioned zeros. We can use synthetic division to do that, and what it essentially means is that in the remainder piece, or the constant side of your column, you need that to add down to a 0. If that happens, then you have found a 0 to your problem, i.e. you found like an x-intercept. So again, we can set it up. So in this case, I'm wanting to test 3. So I'm going to set up my synthetic division. So you're going to make that box, and in this case I'm checking 3, so I input the 3. Now again, I want to use my coefficients here. So the first term is x cubed, so the coefficient is 1. Then I step down to x squared, so here I have negative 6. Step down to x gives me 11. Step down to my constant is a negative 6. Again, I need to drop my first term down, and this is going to give me my new. Now, when I said constant column, that means this column right here is considered your constant column. So your goal is that in this little box right here, okay, so the goal is to get a 0 here. As long as what goes in this box is 0, then we have found the 0 to our problem. So let's see what happens. Again, remember, we are going to do bottom times the box and put it under in the next column. So 1 times 3 gives you 3. I need to add these together. Negative 6 plus 3 gives you a negative 3. Again, bottom times the box gives you a negative 9. I need to add these together. 11 plus negative 9 is going to give me a 2. Bottom times the box gives me a 6. I need to add these together. Negative 6 plus 6 gives me a 0. Okay, so what do we have? Since we obtained a 0 under the constant i.e. remainder spot, we have shown that yes, f of 3 is a 0 of the polynomial x cubed minus 6x squared plus 11x minus 6. Okay. Now, the other thing that we showed here is we showed that f of 3 equals 0. Okay? So this is what we showed, but this is the idea behind what we did. Okay? So again, since this remainder column, or the constant column, ended in a 0, it means that you had a 0 to that particular polynomial. Alright, so if we can do it with regulars, let's also show you that you can do it with, again, the imaginary. So here I want to be able to find f of this complex term. Okay? So what I'm telling you essentially is that this is your c. So again, we can open a box, and we're going to put our c in it. So 2 plus 3i goes in the box. And then we need to create our polynomial. So I start with x to the 5th, so I put in a 1. Step down to x to the 4th is 0. Down to x third. Down to x squared. Down to an x. Down to your constant. Now again, the first thing we do is we drop down that first term, and thus we've set ourselves up. So here, because we're dealing with the imaginary, I would go ahead and kind of run some division notes of some kind. So here again, remember, we're going to do bottom times the box goes underneath. So here, this is going to be 1 times the 2 plus 3i is going to give you 2 plus 3i. So we're going to go ahead and put that in, that this is 2 plus 3i. I need to add these, so that drops down to 2 plus 3i. Now I need to do it again. Bottom. So 2 plus a 3i times the box, 2 plus 3i. I have two binomials multiplied together. You need to FOIL. So in this case, you're going to end up with negative 5 plus 12i. And so here we'll go ahead and put that under the next. So this is a negative 5 plus 12i, and I have to add. So of course 0 plus that means I get a negative 5 plus 12i, and I need to keep going. Bottom, so negative 5 plus that 12i times the box, 2 plus 3i. So again, two binomials, multiply them together. Don't forget your rule, I squared is negative 1. And so in this case, you're going to get negative 46 plus 9i. So here we've got negative 46 plus a 9i. We need to add these together. Gives you negative 46 plus 9i. Let me write this a little diagonal here so I don't run out of space. Okay. And do it again. Bottom times the box. So negative 46 plus 9i times 2 plus 3i is going to come out with negative 119 minus 120i. So minus 119 minus 120i. Again, add them together. And then one last time. Bottom, negative 119 minus 120i times the box, 2 plus 3i. And this is going to end up with 122 minus 597i. So 122 minus 597i. Again, I need to add these together. So when I do that, what you have to pay attention to is that I have 32 and 122. So those get combined. So this becomes 154 minus 597i. This part right here is your r of x. Again, in this case, this would also be your solution. So what do we know? We have found that f of 2 plus 3i is going to yield 154 minus 597i. This would be what we were looking for. So there you have it. Okay, using synthetic division in order to find the result. Now, one thing to keep in mind again, this piece here would be that q of x. So if you needed the q of x, you would have it to write down. However, all we were looking for was this result. Okay, so you need to pay attention, very, very close attention to the questions that you are being asked and give only exactly what it is that you're supposed to find. So there you have it in a nutshell. Everything that you need to know about using long division with polynomials or synthetic division with polynomials. So if you have any questions, please be sure to let me know. Otherwise, enjoy yourself, remember to smile, and I'll see you next time.